years, we've seen lots more of this purposeful arrangement of parts. Here's a nice example. Here's a bug called a plant hopper, and improvements in video techniques have shown that it can leap further than other insects because of an arrangement down on its legs. And if you look at these little bumps, people couldn't see what they were, but in recent years, they were shown to be gears, literally mechanical gears. And most people, when they see this, realize the purpose behind it. So, and I'll skip over this. This is bacteriophage T4. It's just another example of it. Okay, let me skip over to the book. Here's the cover of the book. Just came out a month or so ago. And here are the three key concepts from the book. The first rule of adaptive evolution, the principle of comparative difficulty, and the family line. I think I'll just talk about the first one just because of time issues here. The first rule of adaptive evolution. And a lot of it is based on the work of this man, Richard Lenski, who is a professor at Michigan State. And he has run an experiment for 30 years in which he has grown the bacterium E. coli in flasks in his laboratory. And since E. coli bacteria are so small, they reproduce quickly in about just 1 hour as a generation. And since they're so small, you can grow a lot of them in a small space. You can get hundreds of millions of them in a test tube. Well, he saw throughout his experiment that every now and again a mutant bacteria would come along that could grow faster than everything else. But when he started the experiment in the 1990s, there wasn't the technology to track down the change in the DNA to see what it was that was helping them grow faster. And when he tracked down the first one, he saw that it was a mutation in something called the ribose operon. And the ribose operon, the activity of it decreased. And it turns out that much of it was deleted. In other words, broken, was thrown out. And nonetheless, this was a beneficial mutation. So this makes the point that beneficial mutations don't have to be constructive. They can be degradative. And
sort of like Dr. Michael, I'm sorry to interrupt. I think, correct me if I'm wrong, related to the argument that it's usually used by some of the Darwinists, that if people deny Darwinism is true, then they are denying the antibiotics that they work. And I think it's the same mechanism that the virus or the bacteria or something like that, they actually destroy some part of the genes are destroyed. You'd like to touch upon this point?
Yeah, that's exactly right. It turns out that many of the examples that Darwinists have hailed over the past 100 years or more turn out to be degradative mutations. Examples I like to use concern malaria, resistance to malaria. I've used that in a couple of books. Turns out that many of them break genes that were already there and gives people some resistance to malaria, but now they're missing the gene. Same thing with antibiotics. Oftentimes an antibiotic targets a certain protein, and if you get rid of the protein, then the bug will be resistant to the antibiotic.
And it cannot give this to the other generations after this. It cannot, when it procreates again, it doesn't give the new traits to the new mosquitoes or the new...
Actually, it does give the new traits. For example, there's a disease called thalassemia, which is actually results from breaking one copy of a globin gene for hemoglobin. And turns out that gives the person resistance to malaria. And when they have children of their own, the children inherit the broken gene, and that allows them to be resistant to malaria too, but they're getting a broken gene. They're not getting anything constructive. So you have to separate helpful versus deleterious. That's different than constructive versus destructive. Helpful mutations can be either constructive or destructive, but it turns out that overwhelmingly they are destructive, degradative that we see. And here's one of the reasons why. If you wanted to break a gene, just like if you want to break a car or break a computer, there's any number of places that you can hit it with a hammer and it won't work anymore. But if you want to improve something, there's usually only one or two places where you can, because these things are in pretty good shape already.
That's amazing.
And I came up with something called the first rule of adaptive evolution. Break or blunt any functional coded element, which just means a gene. Break or blunt any gene whose loss would yield a net fitness gain. And that just means more offspring. So break any gene or blunt any gene that would increase the number of offspring. And that's like in the case of malaria, they're resistant to malaria, but they have broken genes. And this is called the first rule because it happens a lot faster. Degradative mutations are intrinsically much faster than constructive ones. Simply because of that last slide, you can break things in so many more places. That means you have more opportunities and it goes faster. So that's the first thing you would expect a species to do when it's adapting to a new environment.
Oh, so, and this is Dr. Michael. It relates also to the finches of Galapagos Island that Darwin saw and witnessed. It's actually something related to this too, right?
Exactly. I've got a number of examples here. So let me just go down to the finches again. Here's that slide again. And one of the traits that people always get excited about in the finches is the fact that you can have thick beaks versus thinner beaks like this. And they say, well, isn't it amazing that random mutation and selection can do that? Well, only 3 years ago was the gene that was responsible for these different traits tracked down. And it turns out that the gene which is responsible, the variant of the gene, is one that has been degraded. It has suffered damaging mutations. And so, again, one of the core examples of evolution, and one of their textbook examples, is actually devolution, not evolution. Okay, so the point is, that pretty much, let me just go back, pretty much everything, all of the mutations that Richard Lenski saw were degradative. 30 of them, over 60,000 generations. And in the book, I also talk about other examples. For example, dogs, the dog breeds that have been produced in the past few hundred years. It turns out scientists have sequenced the DNA of a lot of these, and they're mostly degradative changes that make them have short legs or curly hair or so on.
So how does a Darwinist respond to this, Dr. Michael? Like when he sees these studies, do they deny these studies or fight it back? What mechanism is it?
They do not deny them. So far, the only response I've gotten is that they say, well, sure, everybody knows that sometimes getting rid of a gene will help a species. But there's also lots and lots of constructive changes, which they have yet to point to. Sometimes they will point to instances of what is an apparent duplication of a gene. For example, there are proteins involved in vision, color vision, and it looks like the gene for one beginning protein called an opsin was accidentally duplicated. So during the DNA replication process, this gene was kind of stuttered and it was reproduced twice. And then maybe one of the genes got a couple of mutations that gave it slightly different light absorbing properties. And that could be the basis for color vision. And you could say, well, there's a couple of responses one could say. You could say, well, that's not a big deal because you're just getting more of the same and slight variations in its properties. And you could also say that, in fact, we don't know that that was occurred by a Darwinian mechanism. That is, we just see there's two genes there, and the Darwinists are assuming that it occurred by a Darwinian mechanism.
So it's sort of like a circular argument. They start with the premise that Darwinism, by like working on mutation, natural selection is the true fact, and they prove it by this. So the question comes, like Dr. Beyhi, like about these changes that can happen by adding constructive addition to the DNA. Can it produce different, I'm not talking about species, just a species, different like kingdoms and phyla, and like that we can have like sort of like the Cambrian explosion diversity by these constructive additions to the gene pool, or it's not even proven until the moment?
Do you mean by Darwinian process or,
yes.
or what?
Yeah, this is
what? No, I think there is strong evidence that you cannot do that, and I write about that in the book. Let me show you a slide or two that kind of speaks to that. So here's the Galapagos finches, and if you look at the biological classification of them versus their ancestor, both the ancestor and the descendant finch are eukaryotes. That's the domain. They're animals. They're animals with backbones. They're birds, and so on. They differ only in the two smallest categories, the two bottom categories, species and genus. And so everything above this line is the same. Only below the line is different. And the different categories are substantially different. They require much greater information to pass from one to another. And you, in the book I write that you can represent it by, there are 8 classification categories here. You can represent it by an 8-digit number. And to make it concrete, you can think of it in terms of a sum of money that has, in hundreds of thousands of dollars, and also change, cents. And so in 2 million years that the finches have been on those Galapagos Islands, they've only changed in the pennies and dimes columns. The trivial change, you'd get more money if you put your money in a bank and waited. So it hasn't done much of anything, and that's over 2 million years, and they're not the exception. Here there are fish called cichlids, and let me just say that there are 500 new species in a particular lake in Africa called Lake Victoria. But in the same way, they only differ from each other in species and genus. All the other things are the same. And this is also the case in lakes that are millions of years old. And if you look at other categories, anoles, lizards, honey creepers, birds in Hawaii, fruit flies in Hawaii, a lot of them have developed new species, some new genera, and no new families or higher. So I call that the family line. That is, I think Darwinian evolution is self-limiting because with the first rule of adaptive evolution, species adapt easily by breaking genes to fit into the environment, but then that restricts their change at higher levels because they've already used up all of their extra genes that they could lose, and if they lose much else, then they'll be in big trouble. So I think that Darwinian evolution can do small changes in evolution, can change creatures a little bit around the edges, like the finches, but it can't make anything new, anything beyond the family.
So we can say it's like adaptive, just the adaptation, but it doesn't explain the variety of different types and kingdom and so on. But that takes us, like Dr. Beyhi, to the point of some people they claim that, or some Darwinists, all of them, they say that we have a common ancestor, or as a whole. I'm talking about the first common ancestor. Is there any science that backs that?
People would point to similarities between organisms as the evidence for common descent. So if you think back, they say, well, even bacterial cells have the same DNA code, use proteins and so on. And so therefore, if things descended from a single cell that had those common properties, then that explains how the descendants have those properties. They inherited them. So that's taken as evidence. But it doesn't explain how that first cell got those properties, and it doesn't explain how extra features, extra properties by more and more complex organisms arose. It kind of just says, they were there in the beginning and we have them now, so it must have been by common descent.
I think this is like Dr. Beyhi.
So anyway,
sorry to interrupt. It reminds me of Dr. Dennis Noble. He is a non-religious evolutionist. You can say that. He's not a Darwinist. And he says at the point of if we just bring DNA and put it in a petri dish for thousands of years, nothing will happen. Because it's not about just DNA. It's about the cell. It's about the epigenetics. Yeah. It's more complex than this.
Exactly. Yeah, that's exactly right. DNA, it's like having a book in the library. The book's not going to do anything, and if it's a book on engineering, you have to go and read it, and somebody has to put things together. The information itself doesn't do anything. But we are dealing with folks who want Darwinism to be true. So they're very resistant to arguments that on their face really are problems for them.
Mm-hmm. That's right.
Okay, this slide here is just that that now
yes, Dr. Beyhi. I think it's the internet is cutting a little bit. I'm sorry to.
The year 2000 that when cats added, that had to be designed, and intelligence had to put all the information necessary to make at least one primordial cat or bear or raccoon, and then they could diversify from that, but intelligence is needed all the way from the beginning of the universe, the laws of the universe, and so on, all the way down to the plan for cats versus dogs and bears and so on. And after that, Darwin's mechanism can take over.
That's amazing. So there's also an important point, Dr. Beyhi, the point of Darwinists, they claim that the proof for Darwinism is, as you mentioned, the homology, or the appearance, the outside appearance, that we have the same structure, the bone structure in the hands, the same, maybe the tail of the whale and so on. But at the same time, if we come to the genetic, we can say, ancestry, according to Darwinism, when it comes to very similar animals in the appearance. Like, let's talk about marsupials versus placental mammals, like we can say squirrels, the flying squirrel and the sweet glider. They look the same, but according to the tree of life, according to Darwinism, they are not in the same family. So which argument goes with Darwinism, the homology or genetics? Do you have to stick to one of them?
Yeah, well, they will, these days they will stick with genetics, and they'll make up stories about how convergent evolution produce squirrels in remarkably different branches.
Let's explain what's convergent evolution to the viewer. What's the meaning of that?
Okay. Well, convergent evolution is simply the appearance of traits in different organisms that cannot be traced back to a common ancestor. For example, in many insects have many different kinds of eyes, and invertebrates have different kinds of eyes, and yet the ancestor of invertebrates supposedly didn't have any eye whatsoever, and so those different things develop differently, and some separate branches seem to have similar eyes, and so an explanation that says that invokes convergent evolution would say they just luckily happen upon the same solution to the problem.
It's like the ecosystem of the bat and the whales, we can say, or the dolphins.
Yeah, exactly. Yeah, that's right. And the same proteins, the same genes seem to be involved in these utterly separate creatures, bats versus whales. And ordinarily you'd think, well, that just falsifies descent because they didn't inherit it from a common ancestor. But no, it's rescued by this invoking this other other theory rescue device, convergent evolution.
It's amazing. So what about also, Dr. Beyhi, correct me if I'm wrong, of course, because I'm not a specialist here. The point of genes that we can see and trace that the same gene in different animals, and they do different job. And they are the same, they look the same, but they are different. So also, how does the Darwinists reject or accept this point? Like, how do they deal with that?
Well, they generally don't pay much attention to it. They whatever doesn't fit, well, we'll deal with that later. When similar genes that do different things in different organisms, they'll say, well, that gene was recruited to do something else. Just by using words, essentially try to paper over a situation that they did not expect. And sometimes different genes do the same job in different species, and they say pretty much the same thing. Well, maybe it just was selected to be that way. So, yeah, you will never get a Darwinist to say that the theory looks like it's not explaining something. And that's one of the problems, because it's so flexible that it explains pretty much everything and the opposite equally well. So what a biologist does is go out and see what's in nature and then makes up the explanation post hoc.
That's really amazing. So you're saying here, Dr. Beyhi, it's like a dogma, sort of like the opposite of the same thing that they attack religious people through. They say that religious people, they believe in dogma, they don't change their minds. So it's like the same now, according to Darwin's views.
Yeah, that's right. Yeah, it's kind of hard to be called dogmatist by a Darwinist, because they will, never give up their belief that random processes and selection would explain life. There's a good story about that. There's a man named John Maynard Smith, who was a prominent evolutionary biologist. He died about 20 years or so ago. And once he wrote in a paper, he says, one thing that we know evolution could not produce is a wheel with circular motion. He says, but now, look, we've discovered the bacterial flagellum, which is a rotary motor. He says, so now we know evolution can produce even a wheel. So that's the classic, if it exists, it was produced by Darwinism.
So either ways, it's expected by Darwinism. There's no way.
That's right. That's right.
So what are the points, Dr. Bia, like some people when they say that, okay, you are part of the intelligent design movement, along with other scientists and so on, but they say like you are driven by religion, you're driven by your belief, and they always say between brackets, it's like you are trying to do this because of your previous beliefs. It's not because of the religion, and it's non-stopper. It's non-stopper, sort of like the Big Bang. Like it's the end of everything, where you shouldn't just go and search for any proof, and you are just destroying science by this.
Oh, wow. All right. That's impressive. Well, I, as you might imagine, I disagree with that. Certainly I'm religious, but it's the evidence that is pointing in the direction of design. As I tried to show with that cartoon of the man who was caught in the jungle trap, you can recognize design simply by the physical features of a system. And it's also the case that I myself used to think Darwinism was true. And then I read a skeptical book, and I started to wonder about it myself, and saw that, in fact, the evidence for it was much, much less than I had been led to believe. So it's not based on religion, certainly not for me anyway. It's based simply on the evidence. I mean, you can hold views about the world that are based on, sacred texts or so on. For example, that the world was created in the beginning by God. All right, yeah, I certainly believe that. But if you come up with a Big Bang theory, it's not religious just because it, seems to agree with the sacred texts. It's an independent line of thinking and evidence that comes to the same conclusion, but it doesn't depend on religion for the conclusion.
So it's sort of like some of the biologists, even the ethiobiologists, they say we don't allow the divine foot to go through the door. They don't like to just have any implication that religion is true, maybe because of fear of religion, as Professor Thomas Nagel, he mentioned this in his book, The Last Word. He actually admitted that, and he said that I have to admit it. I fear religion. I don't want the universe to be explained in this way, in the intelligent design way. And he feels bothered that smart people, intelligent people like you, Dr. B, they are religious. He's bothered by this, and he feels like uneasy that how is it possible for smart people to be religious, and he doesn't feel like he's consistent with his views.
Yeah, that's exactly right. Thomas Nagel is doesn't want religion to be true, but you have to admire him for being intellectually honest. At least he says there's a problem here. I don't like where this is leading. I'll try something else, but I at least admit, it doesn't look good for my views. I'm happy with that. Sure, go ahead. It's the problem is the scientists who say, no, if you talk about design, if you say anything that seems to have to point beyond nature to theological or philosophical consequences, by definition, that can't be science. And so only materialism can be science. And that's a philosophical principle. It's not a scientific one. No experiment showed that materialism is the only explanation for things in nature.
Yes.
But that's the world we live in. So you just have to learn to argue against folks like that and try to find ways that you can try to reach them at least, or at least people who aren't quite as dogmatic but are influenced by the materialist scientists.
We have the third way, I think, that
Yeah.
has so many people and scientists.
Exactly.
That's amazing. So what about theistic evolution? Like some people, they take this view, they're religious, they don't want to give up their religion and they believe in their religion, but they think, and so, even in the Muslim world here, we have some people, they are propagating this idea that evolution is true, it's irrefutable, we cannot deny it, but it was directed by God. Do you see here like a contradiction in terms, Dr. Behe, or you see it can happen for?
Well, that's a good point. Theistic evolution means a number of different things. Theistic evolution can mean, well, God made the universe and then kind of left his hands off, and the outplayings of natural law produced life, and not at his direction. And or you can say, well, yeah, I think God was directing the processes to build up life, but we can't tell that. That's matter of faith. The scientific evidence doesn't show that. Or you could say that God made the universe, is directing the processes that make life, and I can tell from the physical structure of the organism that, in fact, it was guided, it was designed somehow, that it was the product of a mind. And so that last option, I think, is perfectly fine, because you're saying the most important point in this discussion is design versus randomness. So if you say that God guided it, and I can see that it was guided because of the functional, purposeful arrangement of parts, then that's intelligent design. People can differ and say, well, I think that God actually directly created these things, or somebody else can say, well, I think all of the information was physically present at the beginning, but it was put there by God. Well, those are details, I think. The important point is that you can tell that it was designed. Theistic evolutionists, on the other hand, who say there was no guidance, well, that's functional atheism, yes. I think. And the ones who say that there was guidance, but you can't tell unless you have faith, I think, well, it's hard to know about that, but I think they are scientifically mistaken. That if they were correct, then Richard Lenski's work in his laboratory in Michigan should have produced something more interesting than broken genes.
That's amazing. Very amazing. Yeah. So what about, Dr. B, your work, like I think it was in the Dover also trial, the point of the flagellum, some people, they attack this and they say, well, okay, we can have a function of bacteria that's less in like we can say in the complexity, and it has a pointy tail, which like is used for like killing maybe its enemies or something like that. Correct me if I'm wrong. So that disproves the point of the flagellum is just made by God, or it's irreducibly complex. How can we respond to that?
Yeah, that's another good point. Yeah, it's called the type 3 secretory system. It looks kind of like a shrunken flagellum with just a needle sticking out, which can be used to pump proteins which kill another bacterium that can be eaten by the first one. Number one, you can say, well, suppose that there was this rather simpler structure, and then it gave rise to the bacterial flagellum. Well, the Darwinists haven't explained how even the simpler structure got there, which is itself pretty complex. And they haven't explained how it gave rise to the flagellum. So all they've said is, why, here's this that's doing something else, and it kind of looks like this other thing, so we'll assume that it was produced by Darwinian processes. And interestingly, in the meantime, since the Dover trial, it's been shown by scientists who are comparing different species and their protein sequences that it looks like the the simpler system actually devolved from the flagellum.
That's interesting.
That is, more complex system was there first, and it gave rise to the simpler system. Mm-hmm. And that is certainly not a Darwinian expectation, and it's rather compatible with intelligent design. If a designer who makes something that's useful and in other circumstances can be broken down to give you something else that's useful, that's foresight. That's planning ahead.
Mm-hmm. That's really amazing. So what about the point of Craig Venter? And it's said that he just created a cell. So is this true that he created a cell from scratch, or it's just he brought a living cell and put DNA inside it? So
yeah. He certainly did not create a cell. From what I understand, he and his co-workers chemically synthesized DNA of one type of organism or one type of bacterium and put it in a remarkably similar, almost the same species of bacteria from which they took out the original DNA, and it started to work. And that's interesting, but it's kind of like saying you'll take the engine out of one car and put it into another car, and wow, look at that, it works. It's amazing that the most modest results that can be spun to support Darwin's theory are given so much publicity. That's the problem. If Darwinists were more honest and modest about their claims, they could do what they wanted to, but they have the media on their side and the schools in the United States on their side, and so they are misleading children into thinking that the evidence for the theory is much stronger than it is.
That's really amazing. We're almost done now, Dr. Beyhi. Really very interesting. And we would like to have a final word for people who say that those people who are attacking Darwinism, they are against science, they are pseudoscientists. I'm sorry to say that, but I was looking to the Wikipedia and I saw that the definition of Dr. Michael Beyhi is a pseudoscientist. That was really ironic,
That's great. Opponents can say whatever they want. You can't stop somebody from saying what he wants. But I got into science because I wanted to know how the world worked. And I thought Darwinism was true, and I have been investigating various aspects of life for a long time. And it's only because I think now that, in fact, it has been wildly overblown and that, in fact, it's not true. It simply doesn't explain life. And it's the biochemical evidence, along with many other disciplines, shows that it's a very poor theory and that it's pretty much falsified. So I would say that somebody who blindly adheres to a theory such as Darwin's, when all the evidence mounts against it, they're the folks who are, not good scientists, because science is supposed to follow the evidence wherever it leads.
That's really amazing. Thank you so much, Dr. Beyhi. We're very happy having you. I think this is the first time you have an interview in the Muslim or with a Muslim or with an Arab.
Yes, it is. It's great.
So what do you think about this experience?
Yeah, it's terrific. Tell some more folks to get in touch with me. I'd be glad to do it again.
That's really amazing. Thank you so much, Dr. Beyhi. Very pleased, very honored to have you.
Okay.
Thank you.
Goodbye. Have a good day.